So a couple things about this part. This is a template that came off Cam Instructor. Just to start out, we're going to program it right where it's at because I didn't modify the template around it all. I'm just going to tell you, I want you guys, when you're writing parts or doing stuff, everything needs to be in the Z negative. It's a better practice to do. It takes less chance of you having to crash. I could set my origin off the chuck jaw face and then program everything out Z positive, but you'll get yourself in trouble because if you go in there and you throw in a program that's written in Z negative and you forget to reset your Z, you're there. You're at the chuck. So I strongly don't like to have my origin at the back end of my part. Could you do it? Yes. Is it a good practice? No. All right. We're going to program this one because it's already there and I don't want to move it around, have to fight all that stuff. But you're going to do an exercise based off what we do together here this morning. The exercise, I do want you to program just like we have been. Everything in the Z negative, okay? Everybody good with that? All right. Okay. So let's go ahead and get started. We'll start out. We'll go into the file properties and we'll just tell it this is lesson 4 lecture for the group name. We're going to use the default library for this. Tool settings, we're going to leave just like it is for this part. Don't really need to change anything. I don't need to change the stock setup. It's already set up. We can take a look at it so you can kind of see what they've done. They came in, told it 1.5, a 3-inch length, and then they used margins, the 50 thou margin, in order to add a little bit of extra on everything. So like the left side of the part, they added 3 inches of what we're holding on to back in the chuck. Okay. And then they set up their jaws, told it that, hey, you're holding on to it at negative 0.5 Z, so a 1/2 inch back from the origin at the end of the part. If I was running this part, I could, but I'd have to go out to the machine. I'd face off my Z calibration, my 0, and then I would have to subtract that length from the Z offset, like back to the back of the part. Seems like an extra step, and like it's just said, it gets you off close to that chuck, and if you aren't paying attention to what you're doing with the next program, you take a chance of crashing. So this is not good practice in my opinion. Honestly, it's just my opinion, but I'm going to recommend that you don't do it this way when you go to machine a part. Could you? Yes. Should you? No. All right. Okay, let's face this thing. We're going to pick face. Go ahead and uncheck the show library tools box. That way it only shows the tools we're going to be using. Yeah. Okay. So up here, we're going to go ahead and we're going to use the A-degree tool. We're going to come over here. I'm going to tell it, hey, we're going to rough at 15 thou per rev. We're going to finish at 5 thou per rev. My rule, and I don't know if I've really talked to you guys about this with feed rates, is most of the stuff on the inserts they give you is going to be the finish feed rate to get a surface finish that you're after. That's what most insert packs and stuff, they give you a range for what they recommend you run it at the finish rate. Roughing wise, I usually do 3 to 4 times that. 3 is my start number. If I'm only running the part, if it's just a one-off part, 3 is going to be my number. I'm not going to push it any harder than that. But if I'm running a lot of the parts, I'll keep bumping that up and pay attention to my roughing cycle, and I'll watch for my insert to either build up heat or the surface finish to get smeared or looking kind of nasty. If it's not a consistent roughing surface finish, then I'm gonna back it off a little bit. But you could get up to 4 times faster, so you could be roughing at 20 thou per rev technically, if you've got the right setup, work holding, all the stuff, all the stars align. In a perfect world, you can really hog the material off there quick, but you just have to pay attention to what your insert's doing. So, and we're going to talk more about that here in a couple days. I got some insert literature I'm going to bring in and we're going to talk about. So, spindle speed here, I'm going to put in the 1040 just because I remember that's what we use, and then my max spindle speed 1200. 1040 was our 80-degree insert for aluminum. I'm going to say that we are going to face part, rough, and finish. going to go over to face parameters. We're going to select points because we've got those points out there. So we'll hit select points. Then we'll click on the box here and we'll pick these boundary points here, which this is our outermost point, and then we're coming into right here. So we'll pick those 2 points for our facing. Let's set the step over at like 30 thou for the rough and 10 thou for the finish. And then the overcut, let's do the tool nose radius, which was a 32nd. Everything else you can pretty much leave alone. Should be able to check mark out. And there's our facing. Okay. All right, let's see here. Next thing we're going to do is we're going to rough this thing. So we'll pick our roughing toolpath. And the chain that you want is basically, we're going to start with our chamfer right here. So I'm going to pick right here, partial chain. And I'm going to I'm going to turn all the way back to this chamfer right here. So you're going to select that whole outer profile of the part. We're going to leave plunge parameters off on the roughing, and we're going to do a finish pass with this tool to hit all the high spots on the diameters to finish them all out. But I don't want it to try to dip down in here. I don't want it to try to dip down in here or on that chamfer at the end. So we'll leave plunge parameters off here in a second. We'll set this up, feed rate. We'll rough it 15 thou per rev. 1040 cut speed with the 1200 max spindle speed. We're going to rough the profile of the part. Okay. Rough parameters. We're going to tell it, we'll leave the depth cut at 100 thou since we're just kind of simulating here. We're going to go into the lead in, lead out. On the lead in, I'm going to tell it to come up at the same 45-degree angle with that front chamfer. That way it's just a consistent move. And then on the lead out, I always want to go up and away from the chuck jaws. You know, that 45-degree exit is pretty much common. I don't change that hardly ever. But I am going to extend the end of the cut. I'm going to go back an extra 150 thou because we're going to use a 1/4 inch or an 1/8 inch parting tool to part this off. So I'm going to go 150 thou extra past the end of the part, turning the OD. Turn on stock recognition, remaining stock. I always do that. It's like a default thing for me. Then I'll hit OK. Everybody good? Yep. It'll recognize that we've already faced off like what was faced off here. Yeah, it just basically looks at what stock's left. Treats it kind of like a remachine instead of cutting extra air. Okay. Excuse me. Next thing, we'll do a finish pass to get these diameters on site or online. So we'll do a finish pass. Tell it we're going to use the last profile, or you could select that same chain. Tell it OK. feed rate, we're going to do like 5 thou per rev at our 1040 cut speed, 1200 max spindle speed. So we're going to finish the profile diameters. What's that? Yeah, we're going to use the same tool. Okay. Up here, we don't really need to do anything here. This is all good, just how it is. We're doing one finish pass, so we don't need to adjust any of that. The only thing we really need to do is our lead in, lead out again. I'm going to tell it, come up at that 45-degree angle, that chamfer on the lead in. And then I'm going to extend the lead out 150 thou again. Still exiting at the 45-degree angle away from the chuck jaw. Tell it OK. And then check mark out. And there's our finish pass. Clean up those diameters, get that face, chamfer, all the way back to here. Everybody look good? All right. Next thing we're going to do is we're going to cut our relief groove. So we're going to go to groove. And we'll just do a chain. Tell it OK. And then basically we're going to do a partial chain starting right here and going to right here. I'll hit OK. Should have that tool 3 there, that 125 wide groove tool. I'm not going to worry about calculating anything here. I am going to set my max spindle speed, but I don't have, I'd have to go look up the numbers, and I'm not going to plug in just random numbers, so we'll just leave it what it is right now for the feeds and speeds. Say that we're going to cut relief groove. For the 3/4 10 thread, because that's the thread we're going to cut. Go to groove shape parameters. The only thing I usually do here, if I'm using a full chain, I tell it to use the stock for the outer boundary. Look at the stock. What's left? You know, that's what I'm doing. Groove parameters. I'm okay with starting 100 thou off. That's okay. 75% step over. That's good. I'm gonna leave 5 thou for a finish pass. I'm okay with that. Everything here looks good. You know, it's gonna rough by going in the center and then work its way out. I'm all right with that. I could, you know, I think I said the other day, I usually do just work negative towards the chuck whenever I'm grooving. So I do typically go with that. Then we'll go to our groove finish parameters. Everything should be good here. Not much needs change other than we need a little overlap down here. Our tool has a 10 thou nose radius on the insert, so we're going to need about a 15 thou overlap, about 5 thou extra. We check mark out. See how that's going to work out. Okay. So one thing you can see here, you can barely see that green line, how it's coming right down with that chamfer there. All right. Now typically, now that chamfer's already cut, right? But that entry motion's coming through there, but it's not colliding, so we didn't get a collision. But I probably wouldn't want that up there. I probably wouldn't want that coming into that wall like that. I would recommend you go into your finish pass here and go to the lead in, lead out, or the lead in, I guess it's just lead in. And on the second lead in here, I would make that go straight, so it just comes straight down with that wall. It's just, we're fortunate that that chamfer was the same chamfer as what that angle was we had it set at. That's why it didn't collide or show a collision. We do that, and then it's going to come straight in. Now, the other question is, well, why you know, why is it starting all the way up there? All this stuff's gone already, right? All this is gone up here. Why is it going all the way up here? Well, because we chained this chain right here. If I wanted to make sure it just isolated down there to the bottom, okay, for one part I wouldn't worry about it. But if I was making a bunch of them, I probably wouldn't want it to do all this feed coming up from down here on that finish pass. So what I would do is simply draw a line across there so I have it. Say break two pieces. I'm gonna break that line right there at that spot. And I'll delete that out. Okay. And what I've done is I've created that groove profile. Refresh everything here. And then if I rechain this, and this time I just chain from here to here, and I hit OK. Well, now I get a collision because I'm coming down too far. So if I change my entry on that lead in second, tell it, hey, you need to come in kind of from away from the wall there, then I don't get a collision. So it saves that extra movement. You don't need to do that, and I just want to show it to you. But you can isolate it just by breaking that chain and not chaining it all the way up. Whenever we chain that full thing all the way up here, it thinks I want to do a finish pass all the way down that wall. Well, if that wall is already to size, there's no reason to do a finish pass down there. Okay. All right. Everybody good there? Okay, the next thing we're going to do, and this is part of this exercise, so everything we've done so far is we've been doing it, and we're going to keep doing it just so you kind of get the groove of it, but I'm telling you, the Lathe's easy to program. You know, it's not bad to program. We're going to rough this out, but we're going to cheat a little bit. I'm going to do it with a finish pass, and I do this sometimes, where I'll use a finish pass, and then I'll tell it, okay, I'll look at how much material I've got, and I will go in and tell it I need to do multiple finish passes with this much step over. All right, so let's go and pick a finish pass up here. And then I'm going to chain this single chain right here. Just that single chain right there. And I'll hit OK. We're going to use the tool 2 here to do this. I tell it feed rate. I'm going to go 15 thou with a 1040 cut speed and 1200 finish or max spindle speed. I'm going to say that we're going to rough concave feature using finish pass, which is like a oxymoron, right? We're going to rough this using this finish pass. Finish pass here, like I said, what we're going to do is we want to know the step over. So what I'm going to do is I'm going to look here at the X value here, that's 0.72. And then I'm going to look at the X value for down here, and that's 0.5. So basically I've got 0.72 minus 0.5. 220 thou divided by 2. I've got 110 thou of material there. I'm going to do that in 3 passes. I'm going to divide that by 3, so I'm going to do like 36 thou passes. I'm going to tell it to do 3 of them. I'm going to leave 10 thou here. Let's just do 35, make it a nice round number. Since we're leaving 10 thou, it'll be okay. All right. I want it to get down in that surface, and in order to get that to do that, I got to turn on the plunge parameter. Tell it allow it to go down in X into that surface. My lead in, lead out. I can't start straight from the right. Remember, we had that the other day when we were doing our little template for the wrench. We couldn't start straight from the right because it was going in that concave surface and the entry motion was trying to crash it. I'm going to just tell it to come down at a negative 135 angle down into the cut. We'll see. We might have to come straight in. We might have to change it, but I think that'll work. We'll give that a shot. check mark out. Oh yeah. And there you can see kind of how you can use a finish pass to do some roughing. Now, could we have used a roughing pass too? Absolutely. Absolutely. We could have. But we didn't quite need to. All right. Now, what I'd like you to do is copy that toolpath. And let's go into the copy. Let's switch the tool over to this center cutting tool here. Tool 5. So we're going to do a 5 thou per rev with the 1040 cut speed. And we're going to finish concave feature using finish pass. Good. All right. Step over. We're just going to say we're just doing one finish pass here, and we're not leaving any stock. We're taking it to size. You should be able to check mark out and let it regenerate. And there you see the finish pass using that center cutting tool along that surface. The leading edge of the insert. Huh? Yeah. It shows the blue lines representing the lead. It doesn't take the radius into account. So when you watch this in back plot, you can kind of see it here. Come on. Ooh. It's got that leading sharp, like if that was a perfect square. Yeah. All right. Threading. Okay, threading with Mastercam. Notice when you look here, there isn't an option. There's thread. There's not a right-hand thread. There's not a left-hand thread. I'm gonna show you how to do it both ways. Okay, it's very simple. It's very simple. So let's pick thread here. It should have a threading tool there for you. The feed rate, you can leave that at whatever you want there. I'm going to change it to inch per rev, which will be dictated by our TPI here in a second. So if I go over here and change the threads per inch to 30, then I go back to that page, notice my feed rate changed to 33 inches per revolution. Okay. Spindle speed, we'll leave that where it's at. We'll tell it, hey, don't go over any over 1200. Comment down here. I'm going to say cut right hand 3/4 10 OD threads. You come back, go to thread shape. Now for a 3/4 10 thread, we could probably calculate that and figure that out pretty easily, but we also have a nice thread table up here. You can click us up here with me, select from thread table. I can tell it that I want a unified UNC thread, UNF, UNC, UNF. And then I can come down here and find the 3/4 10 thread and hit OK. And that will pull in all the thread data for a 3/4 10 thread, just like if we opened up our machinist handbook and went and looked up or did the calculations for the miner diameter. It does that for me. So I don't have to try to figure out what that's going to be. It gives me the nominal average. So like when you look up threads in the machinist handbook, there's a max and a minor, tolerance for the miner diameter. Maximum miner diameter, bottom minor diameter, lower minor diameter, basically. And this gives us the middle number. Basically, if you took the two, added them together, divided by 2. Okay. So, threads per inch, 10. We're good there, which should have pulled in as well. 60 degree included angle, 30 degree thread angle. Everything's good there, right? That's going to affect how the cutter comes into the cut. You know how out there when you're cutting threads, you're moving that compound rest over and over, and it's still feeding along the part, but you're moving over a little bit each time too. The CNC is going to do the same thing based on what we tell it here. It's going to adjust that as it gets into the thread. Now the start position. For the start position, what I'd like you to pick is the end of your part down here, which is at 3 inches. The end position, I'm going to pick the middle of the relief groove right here. Okay. If you were wanting to cut tapered threads, you could do that here. Now you could also, in that thread table, you notice there's all kinds of stuff in here. We could go in and we could do pipe threads. Okay, we could pull stuff out of here that would automatically pull that angle for me if I was doing some type of tapered pipe thread. Or I could look it up and plug in the value. You just have to know what it is. Okay. Allowances here, I'm just gonna shut that off. I don't need that for this. I'm gonna go to thread cut parameters. The format, we need to use the longhand. Our post, I've never had them build it to use the can cycle. So like when we thread manually on the lathe, we use a G76 can cycle to cut threads. Plug in a bunch of integers there to make it do what we want it to do. Our master can post doesn't support that. It doesn't have it built into it. So we just do a longhand post, meaning it'll post out the actual code for each line of movement. But when you're using a CAD CAM system, who cares? Because it's going to post it just as quick. All right. Now the problem there is, looking at that, if I wanted to make an adjustment to the thread, I'd have to come back to the computer and make the adjustment. Not necessarily to the size of the thread. I can comp the thread in out there, but if I want to change like a parameter of the thread, I can't just go into the G76 line and make an adjustment. Like, let's say I had the threads per inch wrong, I'd have to come back here. Where if I was doing a G76 out there, I could go in the G76 line and just change the threads per inch call out there to do it. Okay. All right. A couple things we'll look at here. Amount of the last cut. I always set that at like 2.5 thou. And I almost always, to start out, do at least 3 spring cuts, meaning 3 0 cuts. It happens a lot quicker out here than it does out there. If I'm threading a bunch of parts, so like right now, I set up a machine on Monday for Matt up at CNS, and we're doing tie rods. 3/4 10 inch, 3/4 10 threads per inch, just like what we're doing right here. Right hand on one end, left hand on the other end, for tie rod Hyman joints. That being said, he's got to make like 600 of these. Well, I did 3 spring passes to start, and then I took one away, ran it again, it did okay, threads still fit good. Took another one away. When I went down to 1, it got tight. So I had to do 2, but I didn't need that 3rd pass. So you can always kind of work with that a little bit, but I always start with 3 and then I'll try to take one away, and if I can only do 1, then I'll just do 1. But typically when you're cutting steel and what we're cutting up there, you need at least a couple just to clean that thread groove up. Aluminum, 1 would be plenty. Okay. All right. Acceleration clearance, we're probably good there. We got our 29 degree lead in angle, we're good there. We should be able to check mark. And there's our threads. Now it doesn't show the graphics. I see, somebody's like, what happened there? Why is the thread missing? I don't know, it's a graphics thing. If you watch this in Verify, it will show you your threads in Verify on the lathe. Okay. Everybody good? That's threading. That's as complicated as it gets. Okay, now where people get twisted there, you look through there, you didn't see anything about left hand, did you? So let's say you want to turn some left hand threads. Well, when you turn right hand threads, you go from right to left. When you turn left hand threads, you go left to right. So make a copy of that toolpath. Just copy that threading toolpath, and let's go in the parameters here. I'll change this to left hand thread here, and I'll show you what we're going to change. There's just two things we're going to swap. Actually, there's two things, plus we're going to zero something out. So the two things we swap are right here, the end and start position. We flip-flop those. We're going to end where we started on this one, so we're going to go to 3 for the end position, and we're going to start over at 2.125. Now, the graphic might throw you off, but all you're doing is you're telling we're going to start over here and go from left to right. We're still spinning the same way and everything, but when we cut that the opposite direction, we turn the thread the opposite way. Does that make sense to everybody? Okay. And then the other thing we're going to do is in the thread cut parameters, the acceleration, we're going to zero that out because that's going to be in that relief groove already. And the overcut, I'm going to put 0.2 there for this one. My check mark out, and there is the thread cut left-handed. That's a left-hand thread. They don't tell you that. Necessarily. Okay. Graphics, it looks just like. It's weird. I don't know why it does that. I feel like it should be leaning the other way for some reason, but. That's why I said when the graphics didn't show it. I'm going to say the graphics didn't really show it. I was hoping it would so we could see it, but I can tell you from experience that's how you do a left-hand thread. All you do is just switch your direction. Yeah. What? Yeah. What? I mean, if they ask for a left-hand thread, you got to give them a left-hand thread.
And my dad's he had a pipe freeze over the winter, and it was a left-handed thread. That way it wouldn't have to go out for some odd reason.
Yeah.
And the pipe froze, and he yelled that he
Yeah. So like on tie rods, drag links, stuff like that, like linkages that you can spin and it will open and like you can make adjustments. Anything that needs to be an adjustable rod, they're going to have opposite threads on each end. That way when you turn it, because if it was both right hand, when you turn this side to open it, you're tightening that side up. So yeah. All right, that's threading. Next thing we're going to do is we're going to part this off. So let's select cutoff. Now there is a point that has been created right there, but I want to start my cutoff out here at the outermost and furthest back point. Typically there's not a point there, so usually I have to go here and say I want the intersection, if there's a chamfer on the back of the part or a radius, of the outermost diameter and furthest back wall, which is where that point's at. I'll tell it that we're going to part off workpiece. Cutoff parameters. I'm going to tell it from stock. I always turn on from stock. I got asked yesterday, what if you don't have it from stock? Well, it's going to be 100 thou from where you chained, but what it doesn't take into consideration is anything that's up here. You know, that chain spot, and we're cut down to there, but if I got like extra material up here, I want it to kind of recognize that. So I always turn it on from stock. You know, just let it recognize the stock that's left. That way you're going incremental from it. I'll tell it a 32nd for my tangent point. And the only other thing is we got to cut that chamfer on the back of the part. So the corner geometry here, I'm going to say chamfer, parameters, hit select chamfer line, and I'm going to pick that chamfer right there. It's going to pull in its size and angle. And then based on what we did the other day, we know I need a clearance cut. So I'm going to tell it, turn on the clearance cut from stock again. I'll just tell you guys, if I see that button that says from stock, I'm clicking it. I'm turning it on. I just wish it was defaulted because it's looking at the stock update. You know, it's recognizing what's been cut, what's still there. It's using that intuitively. I don't have I can't tell you any time where I'm like, I need to shut that off. Like I always turn it on. Okay, and I'm sure someday, one of these days, I'll run into a situation where the stock update's giving me something I don't want, so I shut it off. And if I do, I'll tell you about it then. But I don't have a recollection of any time that I've done that. I'm going to turn on a 10 thou clearance cut for the X and the Z. 0.01 for both of those. And that should be plenty for me to then check out and check mark out of this and not have any collisions and get my chamfer cut and my part off. Okay. All right. Lesson 4 lathe. There it is. What you need to do, you got the rest of the time in here, so you can work on this and get this done for next class. I'm going to grade these or check them at the start of class. Whoop, whoop. Is this part at the end of lesson 4. Now, I will tell you this, if you use the roughing like I did for these, okay, if you do that, I would do those separate of each other. Do one and then do the other one. I mean, if you use the finish pass to rough it just like we just did, do one at a time. So you'll have 4 tool pass basically instead of trying to do them all with one. Because you don't really want to touch these diameters with your tool that you're doing that with. Also, make sure you put your Z0 out here. Draw this all in negative Z. So that's going to be a little bit different. Stock setup, make your stock a little bit bigger, like 1.5 inches. And then set your length accordingly based on the part length and what you need to hold on to. But and you can use the workbook or use Cam Instructor online stuff to kind of look at the walkthrough. But it's all on your Cam Instructor, okay? So you guys can go ahead and work on that, get that wrapped up. Other than that, I'm done for the day. Oh, portfolios. If you've got them, you can turn them in back there. If not, you need to make sure you bring it in with you on Tuesday. Okay, make sure you bring your portfolio with you on Tuesday. And I have everybody's rough drafts, right? We're good there? Okay.
I don't have a binder like that, but I have like a little
folder. Those are bigger than they need to be.
What you call it. It's like got the clear front page.
Yeah, and it clips, kind of pinches it. Yeah, that's fine. Most of the time, that's what they come in. Those are just a little bigger than they need to be. Yeah, most of the time, they're just like a little professional portfolio. I'll show you. Yeah, most of the time these get turned in like these things, these little plastic sheets with the clips on them. You don't have to have a 3-ring binder. You can just get one of these folders. This is 25 of them. They're not that much a piece. But,
like manila folder work?
What's that?
Like one of the manila folders?
It needs to be something like this. Not just like it needs to be like some type of. Exactly. Yeah.
They sell those at like Walmart?
Huh? Yeah. Yeah, they sell them. They've got a clear cover on them. Most of them have. Some of them have 3 like for 3 hole punch stuff, like with the little things that fold in there. Most of them have like a plastic clip. Yeah, report covers. That's what they're called. The ones I use are not showing up right now. Yeah. These are the ones I use most of the time. These little Duraclip ones. You get a box of 25 for $98. Or you can get like a box of 3 for like $6, so that really is not a great deal.
Yeah, that's more reasonable. I keep spending too much money on McDonald's every week.
Yeah. So, okay. All right. I'm gonna end the video here.